Okay, when I first saw this, I thought it was quite difficult. All right, I do recommend you watch this guy do the sum as well. Certainly does it a little differently, but he does de-nesting. He just does it a little differently. Does it by a formula. De-nesting is something that's was taught historically, but it's no longer taught. All right, but it's something important to do when you see a root that's nested, like this one here. So let's go through that. The first thing to do is to de-nest the denominator there is assume that it can be done. So I'm writing this over here. All right, then what did I do? I actually squared both sides. Let me write that down for you. So if you square both sides, what would you get? Well, the left side's easy. You just get this. On the right side, what are you going to get? Well, you're going to get A plus B plus 2 root AB. I rewrote that a little differently. I wrote it as A plus B plus the root of 4AB. And there's a point to that. I want to equate coefficients. So what do you mean equate coefficients? Well, I got this A plus B part, all right? I want to make the A plus B. Let me get my eraser out so I can be clear about this. I want this A plus B here to be the M, and I want this radicand here to be that radicand there, all right? That's what I did over here. So M is equal to the A plus B, and the M squared minus 1 is 4AB. All right, then what I do, I got to figure out what the A and B is in terms of M. And let's go through that. One thing you could do here is solve this equation either for A or B. I'm going to solve for B. And what would B be equal to? M minus A. Then I took this, which is B, and I plugged it in here. What would you get? M squared minus 1 equals 4A, and B is M minus A. This is quadratic in form, quadratic in A. So let's write that down. I'll be careful about it. That's going to be M squared minus 1 equals 4 MA minus 4A squared. I want to know what A is, and if I know A, I'll know B. So what do you give here? 4A squared, let's see, minus 4MA plus M squared minus 1 equals 0. And I'm trying to solve for A, and the way to do that is quadratic formula. At least I believe quadratic formula is going to work out pretty nicely. You could also factor it, but I'm saying quadratic form is immediate response to it. All right, so it's twice the coefficient on the square term, so I get 8. It's going to be the opposite of the coefficient on the linear term, so 4m plus or minus. Here comes the tricky part, the radicand. Let's see, I got to square the coefficient on the linear term, so 16m squared. And then I get minus 4 times the coefficient on the square term, which is 4, times the constant, in this case is m squared minus 1. And what do you get there? A equals 4m plus or minus, again, that's an 8. And what do you get there? Well, the m squareds disappear because 16m squared minus 16m squared is nothing. And then what do you get? You get 16. Isn't that convenient? And what do you get now? Well, you get A equals 4m plus or minus 4 over 8. And to reduce that, what do you get? M plus or minus 1 over 2. So there's two possibilities for A now. All right, so A could be m plus 1 over 2, or the A could be m minus 1 over 2. Then the deal about this over here is if I know A, do I know B? And I do. It's right over here. What is going to be m minus A? It's really easy to do. Let me write that down for you. So let's say A is m plus 1 over 2. The B is going to be m minus A. Well, m is 2m over 2. And A would be m plus 1 over 2. What do you get there? Well, let's see, 2m minus n is m. You get m minus 1 over 2. Hope that's pretty obvious. Now we get this over here. And I notice there's symmetry now. Like if A is m minus 1 over 2, the B would be m plus 1 over 2. So it's commutative as well. I see the symmetry and commutation. So whether I write down, the A first or the B first doesn't much matter. But I just use one of them. Now let's put this one down first. All right, so now I know what the nested root is. I de-nested it. Next I'm going to do is write down that the term that we're trying to sum together, the sum n, and just write it down. I got this over here. And then what I'm going to do is, probably, I would say multiply top and bottom by root 2. And you're going to get root 2, and then you get root m plus 1 plus root m minus 1. Look at my eraser. I need some room. I'll erase all this business over here. I'm pretty satisfied I got up to that point. And I want to rationalize it now. How do I do that? Rationalize the denominator, by the way. M plus 1, root of m plus 1 plus the root of m minus 1. Not plus, it's minus, right? Let me get my eraser out. Minus, and that's root m plus 1, and then you get minus root m minus 1. What is that going to give you? Well, let's just do the bottom first. That's going to give you m plus 1 minus root m minus 1. The top is root 2, and you get root m plus 1 minus the root of m minus 1. You get root 2. On bottom, the m's disappear, which is good news, and you get 1 minus 1, which is 2. And then you get the root of m plus 1 minus the root of m minus 1. All right, this is also going to be written as 1 over root 2 times the root of m plus 1 minus the root of m minus 1. Let me show you where that's written. It's written right over here. All right, we're at that level now. What I'm going to do the sum now. And I always, say writing things down might be important for you, but I'm going to do this sum over here, and I just rewrite it. And I'm gonna write this down now, and as I do that, I always say that when I'm doing a telescoping series that I want to write the terms down, and I'll go through that with you. And by the way, I know it's 1 over 2. I'm just writing down this part over here and show there's a telescoping series at this point. So just, writing it down term by term, let me do the m plus 1 first. You're going to get, starting at 1, you get 2, then you get 3. This is an addition problem. Then you get 4, then you get 5, plus, well, yada, 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 right? Where does it stop? It eventually stops at the root of n plus 1. Then it's going to be minus, well, let's take a look. We're starting at 1, so it'll be 0. Then it's going to be root 1. Then it's going to be root 2. Then it's going to be root 3. Yada, 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 until we get to the very end. And that would be what? That would be n minus 1. I like to move back a little bit. A couple of terms back maybe. So that would be root n. And then maybe root n minus 1. And you get the idea that that goes on forever. I shouldn't say forever, in between. So minus, this would be n minus 2 minus root n minus 3. All right, I get my, change the color of this and just say a lot of cancellations here. So root 2 cancels, root 3 cancels. I hope you realize the root 4 would cancel, and there'd be a root 5 canceling as well. Let's work our way back from the bottom. What happens there? Well, this would cancel, and this would cancel. A lot of cancellations. And what are you left off with? Well, let's write that down. You're left off with, I'm not going to write the root of 0 down, by the way, but you're left off with the root of minus 1, that's right here, plus root n plus 1. All right? And I have a coefficient over here, so I'm really left with, if I did that whole sum, it would be root 2 on the bottom, and that's written over here for you. I wrote in different order, though. Root n plus 1 plus root n. Yeah, and it took square root of 1 as 1. Okay, there's two things I did over here after I did it. If I'm right, I'm pretty sure I'm right, but I went to Wolfram Alpha, and I went to Sage. Both Wolfram Alpha and Sage could not do this. Right? They couldn't do it. I had no idea how to do it. However, they can do it numerically. I can force them to do that. And I did check out a few numerical examples to verify that this was okay. I also matched the answer in this guy's video, which I do recommend you watching that video. He does it differently. He does it using a formula for denesting. I don't use formulas for denesting. If you're interested in historical documents, Webster Wells, and this goes back more than 100 years ago, wrote an excellent textbook, and that textbook is on algebra, taught at the high school level. And denesting roots were common. They would denest roots all the time. And it's an important thing to learn, not by formula, but by assuming it can be done and going forward with it. Thank you.